So, notes, factor by grouping. So I just want you guys to pause the video and do the do now A and B and play the video once you're done. For A, the first rule to factoring, the first thing you always got to at least check for is take out the GCF. So I look at A, do I have a GCF? Not with the x's, but the numbers have a GCF of 2. So I can factor out a 2, and what's left then is x squared minus 19x plus 60. And now we need to think, okay, two numbers that add to negative 19, multiply to positive 60. That would be negative 4 and negative 15. So that'd be 2 times x minus 4 times x minus 15. Can I factor any more? No, that's good. Voila, that is my answer. So looking at B, what would I have to do first for B? Oh, the lead coefficient's not 1, so I have to make sure I look for a GCF. There is no GCF besides 1. How are we going to do this one? This one is something you guys did last year, but is reviewed this year. But a lot of people tend to forget it, so I'll make sure we're good with how to do B. So we're going to go on to the next page and actually do B. So we're going to be factoring when the lead coefficient A is greater than 1. And that's when you call it factor by grouping, or you can also call it the AC method. So the method's very similar to our two numbers that multiply to the constant and add to the coefficient of x. But it's just a little bit different. So if we're looking at this one, notice it's the same exact question as we had on the do now for part B. Our lead coefficient is not 1, it's 5. So we're going to have to do a little bit different of a method. So what we're going to want to do, it's called the AC method, because if you think about a quadratic, or I should say just a quadratic polynomial, or a square polynomial, it's ax squared plus bx plus c in standard form. So you, instead of just doing two numbers that multiply to negative 4 and add a 19, you're not going to find those two numbers. You have to do a times c. So you do 5 times negative 4. So you want two numbers that multiply to negative 20 and they still add to that middle number of 19. So two numbers, let's just list out all of the factors. 4 and 5, all right. They are adding to a positive number, but multiplying to a negative. So they're multiplying to a negative, that means they're going to be opposite signs. And if they're adding to a positive, that means the larger factor is going to be positive. So I'm going to make all the smaller factors negative in the pairs. And the ones that add to 19 would be negative 1 and 20. So here's what you do different. Nothing changes with the 5r squared and the minus 4. But what you want to do is you split up that 19r, and it doesn't matter which one you write first. I'm going to write the 20 first. It'll be 20r minus 1r. We're using our factors from negative 1 and 20. And think about how that changes the expression. It doesn't really change it, because if I were to add 20r minus 1r, I would get 19r. So that's just getting back to the same expression. But we're going to use this to rewrite our expression so we can now factor it. So from here, some people also call it factor by grouping, because you want to group the first two together and then the second two terms together. So we're going to factor the first two terms, and then we're going to factor the second two terms. So the greatest common factor of the first two terms, so that's 5r squared plus 20r, would be, 5 for the numbers, and they each share an r. So what's left over after I factor that is r plus 4. And then negative 1r minus 4. This is where you have to make sure if the first term in our grouping, and our first term in the grouping is negative 1r. If that is negative, we have to make sure we take out a negative, because we want it always to be positive. So I take out a negative GCF between 1 and 4 is just 1, so we take out -1, and that would be r plus 4, because it changes the sign of both the factors when I factor out -1. And this is when you should know you are correct, because I have r plus 4 and r plus 4 here. So I have the same factor in each of these. So that's when you know, okay, 99.9% of the time, this is correct. So now you can just factor out the r plus 4, take it out, and what you're left over with after you take out the r plus 4 is 5r minus 1. And that is our factored answer. If you wanted to check your answer, you could just multiply that again just to make sure. If you're unsure, say you're taking a test, you want to make sure you're correct, you could just factor that out. And when you add them together, you should get 5r squared plus 19r minus 4, which is our original expression. So that's always a good way to check. That checks to make sure it's correct. I just want you guys to actually pause the video and try this one. And play it if you get stuck on anything, and we'll go over it once you play it. First step to factoring, always take out GCF if you can. We can't here. There's no GCF other than 1. So now we're going to want to make sure we do, oh wait, Lie coefficient is 4, it's greater than 1, so we have to do the AC method. So you want two numbers that multiply the 9 times 4, which is 36, and add to -12. Those two numbers would be, well, -6 and -6. So I split up that -12x into -6x minus 6x, and the other components stay the same. And now I can do my factor by grouping. I factor the first two, and then I factor the second two. So that would now be GCF of 2x, and that would be 2x minus 3. GCF here, it's negative here, so we have to take out -2, and we're left with, -3, and we're left with 2x minus 3. So we know we're correct, so we have 2x minus 3, the same factor in there, so it'll be 2x minus 3. And what's left over is 2x and a messy minus 3 there, so it'll be 2x minus 3. But wait, I wouldn't circle that just yet. How else can I write this to make it more efficient, to make it look more simplified? If you have the same factor, you can write it as 2x minus 3, and then it's being multiplied by its same thing, so it could be squared. And that's how I'm going to make you guys write it. If you don't write it like that, it's not going to be completely factored, and I will be taking off a point for that. That is because when you guys take pre-calc and when you guys take calc, you're going to have to write it like that. It's going to help you a lot more with more of the difficult questions. So make sure you write it like that. And that's it. On to the next page. I just want you guys to do the checkpoint. So 1, 2, and everyone's favorite. Look at that. Pause the video, play it once you're done, and I'll show you the answers. Here's what I got for my work. Noticing I couldn't take out any GCF right off the bat for 1 or for 2. So we had to do the AC method. Make sure, these are easy to check. If you're like, I'm not sure if I got that one right, just multiply these out, and you should get back to the original expression. So multiply them out. You should get back to the original expression. That's how you know, okay, peace of mind, I got that question right, I can move on. So whenever the Lie coefficient is greater than 1, you can't take it out as a GCF, you have to do factor by grouping. So let's go to the next page. So if I want to completely factor this expression, actually, you know what? I want to see if you guys can do at least the first one. So try the first one, pause the video, and play it once you're done, or if you get stuck. So the way this one's a little bit different is, well, the first step to factoring, always take out a GCF or look for a GCF. That's where this one actually has a GCF. So I can take out GCF. The GCF here is 3, so it'll be 3. Then what's left over is 3x squared plus 4x minus 15. And now, okay, we took out a 3. Our lead coefficient is still greater than 1 inside the parentheses. So we're going to have to, again, do the AC method for inside the parentheses. So keep this 3 outside. Be careful. Make sure you keep this 3 outside. It's very easy to mistake. I know that was a mistake I made a lot. So we need two numbers that multiply to negative 45 and add to 4. Where am I getting that negative 45 from? Well, it's 3 times negative 15. Those two numbers would be 9 and negative 5. So it'll be 3x squared. And it doesn't matter where you can put the plus 9x first or plus 9x second. I'm gonna put it first, and then I'll put the minus 5x second. Doesn't matter which one you put where, you're gonna get the same answer at the end. Now we factor out the first two terms, so it'll be 3, and then be careful with parentheses. I like to use, when it's a different layer of parentheses, I like to use a bracket. So I take out a 3x from the first two, so I'll be left with x plus 3. And then from the second two, I take out minus 5, so that would be x plus 3. Making sure to always keep this 3 out in front. Don't want that to disappear. Make sure you keep that 3 out in front, because that's part of the factored form. So that would be 3 out in front. We're left with x plus 3. It's the same there. Perfect. And then what's left over? 3x minus 5. And that is our answer. And you can multiply it out and make sure that it has the same expression as above. But I also want you guys, if you haven't yet, pause the video, try number 2. So what's different about this one than our previous questions? Well, to me, it has an x squared and it has a y squared and it has an xy in that middle term. So we can treat it exactly like what we have been doing. There's no GCF right now besides 1. So the lead coefficient is 2. I want to do the AC method, so two numbers that multiply to 6 times 2, which is 12, and add to 13. That would be just 1 and 12. And we do the same exact process. So it'll be 2x squared, and then there's a plus 6y squared here. But what we're splitting up now is not just 13x, it's 13xy. So what this would now be is, I'm going to put the 1 first. So it'll be 1, not just 1x, but it will be 1xy plus 12xy. Because when you add them up, they're like terms. And when you add up 1xy plus 12xy, we get 13xy. So same expression, we're just rewriting it so we can factor it. Okay, so let's look at the first two. First two have a GCF of just x, I believe. So I take out an x, and what I'm left with is 2x plus y. And the second two have a GCF of, we got 6. They don't share an x, but they share a y, so 6y. And we're left with 2x plus y. Look at that. We know we're correct 99% of the time because we have the same factor in here. So I can take out a 2x plus y. And then what we're left with is x plus 6y. And that's it. So nothing really changes. And if you multiply that through, you should get back to the original expression. Awesome. So let's look at this last one before the checkpoint. I want you guys to pause the video, try it, play it once you're done. So this is kind of already almost factored for us, because you see we got the same factor here and here. So I can take out x to the 4th minus 16. What we're left with is x to the 6th, y to the 4th minus 9. And now, well, it looks like we can keep on factoring, because the first one's a difference of 2 perfect squares. And so is the second one. So that would also be x to the 3rd y squared plus 3. x to the third y squared minus 3. And it doesn't say, it just says which one's equivalent. It doesn't say it has to be in simplest form. So we can keep on checking and seeing none of these works so far. Actually doesn't. That one works so far, doesn't it? Yeah, it would have to be choice 4. So I was thinking, what that? My hesitation there was like, 3 looks like it could be correct, but if you did circle 3, careful, because this is a sum of 2 perfect squares. We can't factor that inside the real number, so that would stay x squared plus 4. If you did circle 3, you can't factor that. You can factor x squared minus 4. That would be x plus 2. That's a difference of 2 perfect squares. So that would turn out to be x plus 2, x minus 2. And then the other 2 factors, can't do anything with those because they're not a difference of 2 perfect squares anymore. So if they had that as one of our choices, that could be correct, but they don't. So be careful. It wouldn't be number 3. It would have to be number 4. That's a tricky one. So just the last part is just to checkpoint these 4 questions. Pause the video, play it when you're done, and I can show you the answers. Here's what I got for these. Make sure for A, I'm going to try and highlight the biggest mistakes I see on these. For A, make sure you take out that GCF first and carry it all the way through. Mr. Math Guy is okay if I don't take out the GCF right off the bat. Yes, but I noticed, if you don't take out the GCF right off the bat, it's tough to see it. You might have got something like this at the end, x minus 1, and then 36x minus 4, and you might forget to take out GCF out of 36x minus 4. So always take out the GCF first. You don't technically have to. It makes the question so much easier, and stops you from making a mistake potentially at the end. B, the biggest thing for B is these are both difference of 2 perfect squares, so we could keep on going and factor each of those one more time. C, the biggest mistake for C is that I feel like a lot of people usually don't see that 625 is a perfect square, so they circle that answer there, but it is a perfect square. It's 25 times 25. So you should get to this step, and then you can't factor x squared plus 25 anymore because that's kind of like factoring x squared plus 4. They are 2 perfect squares, but it's not a difference. They're adding, so you can't factor it. You have to factor x squared minus 25 because that is a difference of 2 perfect squares. And for D, I feel like the biggest thing for D is just maybe circling your answer here. Make sure you just write it's the same factor, so you can write it as the factor being squared. You do need to write that like that it is the most completely factored form. That's it. Go ahead and start the homework.